For our first week in this course, we're going to review some very basic mathematical laws. Now, these laws are very important to pre-calculus, so I think we need to make sure we understand how to do them and how to use them. So the first thing we're going to review is how to add, subtract, multiply, and divide integers. And then once you know how to do this for integers, you can also use this for real numbers. So that includes integers and decimals and square roots. After we review this, the next thing we're going to review is when we have an equation with two variables, and I give you one of the variables, we're going to review how to solve for the other variable. So, how to solve for a variable in an equation involving two variables. And then the last thing we're going to review is the Pythagorean Theorem. So we're going to learn how to use the Pythagorean Theorem. So let's get started. We're going to work with this first topic here, adding, subtracting, multiplying, and dividing integers. So we're going to start off very basic. We're going to start with adding integers. First off, let's review what integers are. So you're familiar with the numbers 0, 1, 2, 3, 4, and so on. These are whole numbers, but we're also going to put negatives in these numbers. So this is going to go out to negative infinity, and this is to positive infinity. So these are our integers. Let's add the following: 5 plus 3, negative 5 plus negative 3, negative 7 plus negative 10, 8 plus negative 3, 3 plus negative 8, negative 2 plus 5, and then one more, negative 4 plus 1. So write all of these down and see if you can add them, see what you remember, and then we'll go through them. Okay, so when we have the same sign and we're adding integers, we just add them like normal. So this is 5 plus 3, which is 8. And we keep the sign. So both of these are positive numbers, so our answer should be positive. If we're adding integers and we have, they're both the same sign, so they both are negative numbers, we add the numbers. 5 plus 3 is 8, and we keep the sign. Okay? So here, these both have the same sign, so they're both going to be negative, and 7 plus 10 is 17, so we get a negative 17. Positive, positive make a positive, negative and negative is a negative. These two are also negative, so we get a negative. So that's the first three problems. Now here we're going to have opposite signs. So you see you have a positive 8 and a negative 3. Okay, when you have opposite signs, you take the bigger number and subtract the smaller number, and then keep the sign of the bigger number. So this is 8 plus negative 3, so 8 minus 3 is 5. And the bigger number is 8, so it's a positive 8, so this is going to be a positive 5. And you can also think about this as you have $8 and you owe $3, so you're going to have $5 left. Okay, we're going to do the same thing here. They have different signs. We have a -8 and a +3. So we take the bigger number 8, subtract 3, we get 5, and we're left with this negative because the bigger number is negative, so it's a -5. Again, you can think of this as you have $3 and you owe somebody $8, so you're going to be left with owing someone $5. Okay, so let's try these two. 5 plus -2 will be +3 because we go with the bigger number. This one's a positive. And again, these are opposite signs, -4 plus 1, so we subtract, we get 3, and we take the sign of the bigger number. Okay, that's not bad, pretty easy. Let's talk about subtracting integers. I see students make a lot of mistakes when it comes to subtracting integers. So let me give you a bunch of problems we want to find. And you might want to write down these problems and try to figure them out on your own, and then see if you can get the same thing I get. Okay, let's get started. One thing you can do when you have subtraction problems is you can always make them into an addition problem. Okay, first let's start with this problem. This one's really easy. 5 minus 3 is 2. Simple, right? You can make this an addition problem. And what I mean by that is, where you see 5 minus 3, what you're going to do is change this sign and then change the sign of this number. So I have to make two changes. When I change this one, I change this one. So this is the same thing as 5 plus a -3. So you have $5, owe $3, you're left with 2. This is exactly what we did just a minute ago, when we have different signs and we take the sign of the bigger number. Okay, the second one, 3 minus 5. So 3 minus 5 is going to be the same thing as, I'm going to write it up right above it, change this sign and change this sign. So now this is 3 plus a -5, which we have different signs. We add them, we keep the sign of the bigger number. So this is -2 because 5 minus 3 is 2, and then we keep this sign. And you could also just follow the original subtraction. 3 minus 5 is -2. I prefer, personally, this changing the signs because it's going to become really helpful with these more complicated examples. Okay, so number 3, -7 minus 10. Here I'm going to do exactly what I did just a minute ago where I changed the sign. In fact, let me change it right here. So I changed this sign and I changed this one. So this is -7 plus a -10. They have the same sign, so we add them. We get 17, and we keep the sign. So both of them are negative, so we get -17. How about this one? -7 minus a -10. Okay, exactly what I said before. Change this sign and change this one. So this is positive and this becomes a positive. Now this is the same thing as -7 plus a +10. So these are opposite signs. Take the bigger number, subtract the smaller, we get 3. And we keep the sign of the bigger number, which is +10. So we get a +3. This is the same thing as 10 minus 7, which is 3. Okay, let's use that for these here. 8 minus 3, well that's obviously 5. 3 minus 8, this is going to be a -5. Again, you can use this property where we change this sign and change this one. How about this? You owe $2 and you owe $5 more, so you owe $7. Again, you can change this sign and change this one, and then you're just adding these two. 2 minus 5, change this one, change this one. The only difference between 7 and 8 is this is a positive 2 instead of a negative. So we have opposite signs here. 5 minus 2 is 3, and we keep the sign of the bigger one, so this negative. Last one. You notice I had parentheses here. That's just so you make sure to see this negative. You could put parentheses around this one if you want. Sometimes you'll see this in math. Most of the time you'll see parentheses around it. And once in a while you won't have parentheses, but that's okay. So what we're going to do is we're going to change this to a positive, which means we have to change this one. So this is the same thing as 2 plus 5, which is 7. Great, now we know how to add and subtract integers. Let's talk about multiplying and dividing integers. So I'm going to make a chart, and this chart is going to help us take care of the signs. Now, we're going to we're going to multiply and divide numbers just like normal, and then we're going to worry about the signs later. So what I'm going to do is I'm going to say first number. In fact, let's do it in a different color. Let's go with blue. Our first number, our second number, and our result. Okay. Now I'm going to give you two numbers. I'm going to ask you to multiply them or divide them. For example, if I say 3 times a negative 5. So here I want you to multiply 3 and a negative 5. First number means the one that you see first, and second number means the second number that you see. Okay, and then the result is what you're going to get when you finish this problem. So what we're going to do is we're going to ignore the negative for a second. We're going to just multiply 3 and 5, which is going to be 15. And then after we multiply the numbers, then we're going to worry about the negatives. And how we're going to deal with the negatives is by using this chart. Now, I think it's easier to kind of memorize the chart, but it's up to you. You can write it on the side or something. And I'm going to teach you an easy way to remember it. So if you have a positive number for your first number and a positive number for your second number, like 3 times 5, both being positive, what you're going to have is a positive result. So you're going to get positive 15. Okay. If you have a positive number for your first number and a negative number for your second number, you're going to get a negative. If you have a negative first number and a positive second number, then you're going to get a negative result. And then if you have a negative number as the first number, a negative number for the second, and that will make your result a positive. Now how you can remember this is what I was taught. And I think it's silly, but it's a good way to remember this. If a good thing happens to a good person, well, that's good. If a good thing happens to a bad person, well, that's bad. If a bad thing happens to a good person, that's bad. And if a bad thing happens to a bad person, then that's good. That's how I remember it still, even to this day. Okay, so for this one, we have a positive 3 and a negative 5. 3 times 5 is 15, and now positive times a negative is a negative, so our answer is negative 15. We could do this with division as well. So let's say we have 20 over a negative 2. This is the first number I see, 20, that's positive. This negative 2 is negative. 20 divided by 2 is 10. And a positive divided by a negative is going to be a negative. It's following this rule here. Okay, let's put this chart to work. Let's get some examples. So I'm just going to give you a bunch of them. Usually I put parentheses around my negative numbers Sometimes I might not put it around the very first one. I just want to not get the multiplication confused with this negative. You don't have to do that. You will probably see it in your homework where they have parentheses around one of the numbers. Okay. Oh, and another thing I do, this is just me, when I do division, sometimes I write it like this, and sometimes I write it like this, and you should know about this as you watch my videos. This is the same thing as negative 15 over 5, and this is the same thing as 21 over negative 7. Sorry if that's confusing. For some reason, I like both of these, and I just kind of interchange them. So maybe I should, let's write this as negative 15 over 5. And then we can erase this one, put 21 over negative 7. Okay, so take a minute and try to multiply or divide these, and then see if you get the same answer as I do. So pause the video and try these problems. All right, so 3 times 4 is 12, and we have a positive times a negative, so we'll get a negative 12. 8 times 2 is 16. They're both negative, so we end up with a positive 16. You can put a positive here if you want to, but usually we don't put positives with numbers. If we don't see a positive, then it's assumed to be positive. If we don't see a negative, it's assumed to be positive. Okay. 3 times 9 is 27, and negative times a positive is a negative. 15 divided by 5 is 3, and then we have a negative. Negative over negative is positive, and 40 divided by 4 is 10. So positive 10. And this last one is negative 3. Okay, I think we have covered adding, subtracting, multiplying, and dividing integers. So let's move on. Our next topic is solving for a variable in an equation with 2 variables. So the variables we're going to use most of the time are x and y, but you could see other variables. For our purposes, at least in the first week of our pre-calculus course, we're going to just use x and y, so that's what I'm going to use today. So I'm going to give you an equation. Let's let the equation be 2x plus 7 is equal to y. First thing I want to do is I want to solve for x. So let's solve for x. And that means I want to get x is equal to something. But I want just x. I don't want anything else with the x. Just want x is equal to something involving the y and the numbers. So let's see if we can do that. That's the first step. So we have 2x plus 7 is y. So let's move the 7 to the other side. And then divide everything by 2. Okay, all of this should be review. Now what you're going to see a lot in the first couple of sections of the pre-calculus textbook is we're going to give you a particular value for x, and I'm going to ask you what is y. So I'll say something like, let x equal 1. What is y? And all you have to do is plug in 1 into your equation. So if x is 1, we have 2 times 1 plus 7 is y, and we just simplify this. We have 2 times a positive number, positive 1, so we get 2 plus 7, and 2 plus 7 is 9, so y is 9. Let's try a different one. Let x equal negative 5. What is y? Again, we're going to plug that into our equation, which is 2x plus 7 is y. Okay, plug in -5 wherever you see an x. So 2 times -5 plus 7 is y. All right, here we're using our multiplication property. This is -10 plus 7. And here we're using our addition property. This is equal to y. So this will be -3 is y. So when x is -5, we get y is -3. Let's do one more. Let x equal 0. What is y? You're going to be plugging in 0 a lot to find the intercepts. So this is a good problem to try. Again, this equation is 2x plus 7 is y. So just plug in 0. Anything times 0 is 0. So we get 7 is y. All right, now we're going to do this backwards. I'm going to give you a y and I want to know what x is. Okay? So I'm going to erase this piece. So if you didn't copy it down, just go back in the video and copy it. Okay. All right, so now I'm going to say let y, write it the way I wrote the other y, let y equal, let's say 3. What is x? There's a couple of ways to do this. You can start with what you have, which is 2x plus 7 is y. And plug in 3 for this y. And then solve for x. So you're going to move the 7 to the other side. That's -4 is 2x. So you get x is -4 over 2, which is -2. The second option is in the very beginning where you have your original equation, you solve for x. And we did that already. That was the very first thing we did, so we solved for x. And now we can use this, where we plug in -3 into here, 3 into here. So if we're going to use this, we see that we have x is equal to 3 minus 7 divided by 2, 7, 6, 5, 4, which is -4 over 2, which is -2, which is what we got this way. It's actually easier to do it this way by solving for x first, because every time we plug in like this, we're going to solve for x. So this actually makes less work for us if we have several problems we need to solve. So let's try another one. We're going to let y equal -6. What is x? Okay, I'm going to write that equation for x again. X, we said, is y minus 7 divided by 2. So then plugging in -6 for y. Okay, now we have -6 minus 7, which I'm going to make it as -6 plus a -7. Remember, you change this sign and change this one, divided by 2. Okay, so this is -13 divided by 2. And you can leave it just like that. That's what x is going to equal. Let's do one more. So let y equal 0. What is x? Okay, let's write the equation for x. Plug in 0 for y. 0 minus 7 is -7, so we get -7 over 2. Let's try another equation. So suppose we have the equation x squared plus y over 3. Let's let it equal 10. I'm going to give you 3 x values. I want you to find the y values. Then I'm also going to give you 3 y values and ask you to find the x value. So here we go. I'm going to say x is equal to 0, x is equal to 1, and x is equal to -5. So this is what I want you to find. What is y for each one of these? And then down here I'm going to switch this up. I'm going to say y is equal to 3, y is equal to, let's go with -1, and y is equal to 0. And then I want you to find x. Do you think you can do these? Maybe pause the video, write these down, and also write your equation down and see if you can find them and check with me. Okay, I'm going to start with this very first one. X is 0. All I have to do is plug in 0 here. Okay, I could also solve for y. So maybe that would be the easiest thing to do first. I'm going to solve for y. So I'm going to multiply both sides by 3 because I want to get rid of this 3 here. I want to get y is equal to something, and you see this is divided by 3. So let's multiply every single thing by 3. And that would actually be 30. And then from there, I move the 3x squared to the other side, and I get y is equal to -3x squared plus 30. And so all I have to do now is just plug in 0, 1, and -5 to find these y's. So if I plug in 0, I get y is equal to, well, this is 0 plus 30, so I just get 30. The next one is 1. So if I plug in 1, I get y is equal to -3 times 1 squared plus 30. So this is just -3 plus 30, which is 27. And we have one more to do. Let's erase this. The last one is x is -5. This might actually turn out to be a big number. So y is equal to -3, -5 squared plus 30. Okay, we got a lot of things going on here. First, we need to square -5. So -5 times -5 is a positive 25. And then we multiply it by a -3 and add 30. So you have a quarter, and you have 3/4, that's 75 cents. And then we have a negative plus 30, so that's 60, 50, 40. Yeah, -45. So that's the last one. So we found these 3. Okay, let's move on. Let's do these. So I'm going to give you the y value, and I want to find the x. Now what we can do is we can sort of figure out x. I'm going to move this y over 3 to the other side, and then that's solving for x squared. And then to actually figure out what x is, we would have to take the square root. So yeah, we can solve for x for this. We're just going to have to be very careful. So let's take this original equation and solve for x. So move this to the other side and then take the square root. Let's do that here. So this is x squared is 10 minus y over 3. Now we have to be careful when we take a square root. When you take a square root, you get a positive and a negative value. Just like that, okay? All right, so let's start with this number 3. And then I'm going to plug in -1, and then I'm going to plug in 0 and see what happens. So x is equal to plus or minus square root 10. So we said the first one was 3. So minus, here's the y, 3 over 3. So x is equal to positive negative 10 minus 1, which is positive negative square root 9, which is positive negative 3. So we're going to get 2 values. We're going to get either 3 or -3. So that's what I'm going to put here, 3 and a -3. Okay, let's try this one, -1. So we'll go back to this equation right here. The only thing we need to change is we need to put a -1 here. So that's going to change this piece, and this piece. Okay, now we got a fraction. We need to be careful. We learned how to add and subtract integers, but we can include fractions into this as well. We have a subtract, a negative, so we change the sign of both. And 10 is the same thing as 30/3. And then we're going to add these two fractions. So 30/3 plus 1/3, that's 31/3. And I'm actually just going to leave it like this for the moment. So this is our answer. X can be a positive root 31/3 or a negative root 31/3. Oops. Okay. Last problem, we're going to plug in 0 here. So let's erase this and plug in 0 for y. So then you get 10 minus 0, so we get plus or minus root 10. So that's going to be our answer here. Root 10 or negative root 10. And this equation we're going to see is a parabola, and a parabola looks something like this. And you can see that for every x, you'll have 2x values for the same y value. So wherever this is located, you're going to have 2 x's for every y value. All right, let's move on. The last topic we're going to talk about is the Pythagorean Theorem. And this theorem goes with right triangles. So a right triangle means that you have an angle in your right triangle that's 90 degrees. And you're going to have 3 sides to every triangle. This is going to be side A, this is side B, and this is side C. Of course, you can label them whatever you want. You could call them X, Y, and Z. That's another thing you could do. X, Y, Z. And you could also put them in any order. So you could call this one B, this one A, this one C, or this one B, C, A, however you want to do it. But the rule is the sum of the squares of the 2 shortest sides is equal to the square of the longest side. Okay, so for our picture, the longest side here is C, which we call the hypotenuse. And on this triangle is Z. So longest side, another word for it is hypotenuse. So I'm just going to go with this triangle here where I have A, B, and C, and you could figure it out. It's going to be the same thing for X, Y, and Z. The equation is a squared plus b squared is equal to c squared. So the sum, here's the sum of the squares of the 2 sides, a squared and b squared, is equal to c squared. And all of these numbers are lengths, so they're going to all be positive. For this particular triangle, it's x squared plus y squared is z squared. Okay, so I want to do a couple problems involving the Pythagorean theorem. So let's scroll down. Okay, so suppose we have a triangle, a right triangle, and I tell you this side is 3 and this side is 4. What is the length of this longest side? What is C? Well, looking back at what I drew, So this is A, this is B, this is C. We know that A squared plus B squared is C squared, and that's how you're going to find C. You're going to solve for C here. So you can plug in A and B. You can see that A would be 3. So 3 squared plus B is 4. 4 squared is going to be C squared. Let's add this up. So 3 squared is 9. 4 squared is 16. 16 plus 9 is 25. So that's C squared. But I didn't ask for C squared. I asked for C. So to find C, you just take the square root. Now when we take a square root, we get a positive and a negative. But because we're dealing with lengths of a triangle, we only take the positive number. So we have a length of a triangle, so we get that C is equal to 5. And that's going to be our final answer. So that's not too bad. The next thing I want to do is I actually want to give you the hypotenuse and ask you to solve for one of the sides. Okay, so let's try that. So let's say, and let's change the way this right triangle looks. Okay, let's say I put it on its side. I want to call this side A. Let's let this side be 2, and this side be 9. What is the length of side A? The two shortest sides are always the sides of the right triangle, okay? So how we can solve for A is we're going to use the Pythagorean Theorem, which says A squared plus B squared is C squared. The longest side is always the side opposite to the 90-degree angle. So this is going to be C. And this one will be B. Okay, so we're just going to plug all of this information into the Pythagorean Theorem. So B is 2, so we have 2 squared is equal to C squared, which is 9 squared, plus A squared. And now we're just going to solve for A. So this is solving for the variable A in an equation with 3 variables. But now, since we know what B and C are, we're actually just solving for one variable where this equation just has a bunch of numbers. So let's continue this. This is A squared plus 4 is equal to 81. Subtract 4 from both sides. We get 77. And then take the square root. Now remember, when we take a square root, we get a positive and a negative, but because we're dealing with a length of a triangle, we're only going to take the positive value. So this is the length of A.